Hello, this video is about equilibrium. So the question asks us which factor does not affect the position of equilibrium for the Haber process below. The key terms are highlighted for you. So let's look at the options. Option A, double the volume of the container, followed by increasing the temperature by 10 degrees, removing V2O5, which is the catalyst, and lastly, adding nitrogen gas. So in order to solve this question, this is the concept that you need to remember. So the Chatellier's principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium moves to counteract the change. This is essentially so that it returns back to its original conditions. So there are a few conditions that will shift the equilibrium towards the right or the left. And these conditions include concentration, temperature, and pressure. So let's take a look at the first factor, concentration. If we have an equation that looks something like this, increasing B will shift the system to the right. Because if you think about it, now you have so much of B, which is a reactant, you need to make more products to achieve equilibrium. What if you add C and D? The equilibrium will shift to the left. So essentially, if you go up, the system will try to bring it back down. And if you go down, the system will try bringing it back up. However, if you add more solid, which is A, it will not affect the concentration. Only gases affect the position of equilibrium, because the concentration of solids are usually constant. Right. Let's look at the next factor, temperature. So if the reaction is endothermic, which means delta H is positive, you can treat delta H as a reactant. So if we increase temperature, the reaction is going to shift to the right, producing more products. Because if you're treating delta H as a reactant, you want to produce more products in order to achieve equilibrium. However, if the reaction is exothermic, you're treating delta H as a product. So if you're increasing temperature, your system will shift to the left, producing more reactants. If you decrease temperature, the system will shift to the right, producing more products. Lastly, pressure. If you increase pressure, the system will try to decrease the pressure. So how do we know whether reaction will shift to the left or will it shift to the right? This depends on the number of gas molecules. Let's take a look at the example again. So the reaction here. On the left side, which is the reactant side, there is one gas molecule. And on the right side, there are two gas molecules. Now the number of moles is proportional to the pressure. So if we increase pressure, the system will move to the side with less gas molecules. So in this case, it will shift to the left. What if we increase volume? Then the pressure will decrease, right? So the system will move to the side which has more gas molecules. So let's take a look at the question once again. So which factor does not affect the position of equilibrium for the Haber process below? If we double the volume, means we are decreasing the pressure, because remember, volume and pressure are inversely proportional. So it will affect the system, because pressure is one of the factors that affects the equilibrium. So we can cross this out. Next, increasing the temperature will also shift the system to the left because it is an exothermic reaction. So we can cross this out. How about removing V2O5, which is a catalyst? What happens? So a catalyst essentially speeds up the reaction, both the forward reaction and the backward reaction, so there will be no changes to the position of equilibrium. So this is our answer. But let's look at option D, just to be clear. Adding more nitrogen gas increases its concentration, shifting the reaction to the right, producing more products. So we can cross this out as well. Therefore, your answer is C.